Fluoride contamination in the groundwater is a major global problem. There are two types of fluorosis. One is dental fluorosis, another is the skeletal fluorosis. Dental fluorosis spoils the enamel on the teeth, and the teeth get weakened and they become yellowish. And in skeletal fluorosis, the bones become very weak, indicating early onset of osteoporosis. Fluoride contamination has now become a major issue in the state of West Bengal. Almost 7 districts in the states have been adversely affected by the fluoride contamination in the groundwater. Typically, fluoride concentration occurs in the range of 2 to 5 milligram per liter, and in some cases it can go up to 10 milligram per liter, even 20 milligram per liter in certain cases in different places of India. So WHO, World Health Organization, has set up a limit of 1.5 milligram per liter of the fluoride concentration in the drinking water, and the most desirable concentration is around 1 milligram per liter. There are various processes for treatment of fluoride contamination for the mitigation of the fluoride in the groundwater for drinking purposes. These include membrane-based separation process, ion exchange, adsorption, etc. Among these, adsorption is the cheapest and easy process. It is very easy to scale up as well. So therefore, adsorption becomes very popular nowadays because most of the fluoride contamination occurs in the rural India. So in this regard, the adsorbent that is most commonly used throughout the whole world is activated alumina. So activated alumina, the major problem of activated alumina is its adsorption capacity is very low, around 5 to 10 milligram per gram. So therefore, the filter bed that will be using the granular activated alumina, it needs regeneration, and that means a chemical regeneration at least once in a week. So the major problem with that is if the chemical consumption is high, the operation and maintenance is expensive, and also the concentrated fluoride that has been absorbed in the media will be coming out, and that will recontaminate the groundwater. So in this regard, we have developed this aluminum substituted hydroxyapatite carbon. So here we are trying to mimic the nature. In nature, in the rock, there is a mineral phase called hydroxyapatite, and that basically absorbs fluoride. So the apatite phase is developed in the carbon granule, commercial activated carbon granules, which have a size 1 to 3 millimeter. It has a very high capacity, 105 milligram per gram. There is no regeneration required during its life of 1 year or 1.5 years. It's basically a design problem. So life of the filter we can say up to 2 years, and we do not require any chemical regeneration during that time, thereby reducing the operation and maintenance cost tremendously. The spent material can be used as it has a strong high calorific value, so it can be piled with coal, lignite coal, and can be used as a fuel. There is no power required for the domestic filter. This filter is highly scalable. It can be scalable up from 100 liter per day to 10 meter cube per hour capacity. It is a very low cost filter. The cost of the treated water becomes 1.3 paisa per liter, and the absorbent can be prepared at room temperature without applying any pressure using the commercial chemical. So therefore, the material becomes low cost, and it gives a low cost solution, and the impact will be tremendously high if this technology is spread throughout the rural area. That will have a high societal impact. It will be benefiting the health of the people, and the cost of the medical treatment, annual cost of the medical treatment, will be reduced tremendously. So the social impact of the technology will be extremely high. The midday meal of the school is also cooked by the treated water that is coming out of the filter. Since there is no iron in this water, so you can see the rice becomes very, very white. So its taste is also good, and it is being cooked in a very short period of time compared to earlier cases.